Today I'll cover a mouse interaction script. RTSs tend to use a lot of mouse controls and mine is no different. I'll first demo it through the event log, then show a test script primarily to show how to use it, and then finally step through the interaction class. Here the debug log is reporting what the mouse does. The numbers are the XY coordinate on the screen. If I move or zoom, I get a move or zoom event. But it also distinguishes single click, double click, drag start, drag move, and drag end for each button separately. It's harder to demonstrate, but drag will replace move if the cursor moves too much when it's down or stays down too long. Zoom also includes a zoom change value along with the position, as better zoom controls usually take into account zooming to the mouse's location, not just the center of the screen. I follow the practice of placing all my managers under child classes of an object called managers at the top of the hierarchy. Interaction Manager is the only one right now. I also put the test script in the same spot, which is temporary. I will be disabling it, but it's good to keep around if I need to make changes and test them later. Now I'll show the test code, because that shows how other code will use this. It's simply listening to action events. Every method returns a vector2, which returns the screen position, except zoom, which also includes the zoom level. You'll notice there are many events. We have separate ones for each button and for each button state. That's 17. 5 for each button plus zoom and mouse move. Now to start going into the Interaction Manager class. So the file includes a couple of enums at the beginning, which include the interaction source for mouse button 1, 2, and 3, and also an interaction type for calling out click, double click, drag start, drag end, and drag move. Additionally, there's also the interface, which is the InteractionManager, which duplicates all the events that we just saw in the test. Next, we have the Interaction Manager class. It's a mono behavior and has the interface as well as an interface for iSerialization callback receiver. That's specifically just to allow this to support compile and continue playing in Unity. So I'm going to minimize this, but that's effectively how I set my Singleton instance. The next section that we have is the events. Inside it, we have another serializable class called response fields. This includes clicked, double click, drag start, drag move, and end. And these are each arrays that include the vector2, broken into 3 separate calls, one for each button. Now, going down a little farther, we find the zoom handler and we find the zoom mover events. So we can store all of our actions to call back here. We can also respond to them or react to them through this .response.dragEnd or .zoom handlers, similar to what we've got wired up here for the add mouse listener. So this is the function to add the mouse listener. We call out which interaction source, which interaction type, and then the method that's going to be used to respond to it. There's also, of course, a remove listener to do the exact same thing but remove the event. On top of that, here's the ones for the add zoom listener and add move listeners. Basic interaction stuff. Okay, now we're going to start getting into the more complicated area of this, the actual mouse handling. To begin with, another serializable class, and this is to store the previous fields, what it was in the last frame. So to begin with, we're getting the mouse position, we're going to have the mouse release time, and I'm going to explain how these variables are actually used down later when we actually start to use them. So then we also, of course, have this .previous, which references all of these. And then we also have a mouse moved and a mouse position to tell us what the current mouse, did the mouse move this frame, and what is the current mouse's position. Okay, so to begin with, in the start function, we clear all the values. We set it to -100,000, so that clearly will not trigger the double click time, for instance. Next, we're going to set during the update, we're going to call each one of the types of things that we might react to. We're going to handle the mouse moves, then the zoom. After that, we're going to handle the mouse check for clicks, double clicks, all the 5 different types of actions that happen to it. But we're going to do that separately for each interaction. That allows us to easily call these out so that we can respond to each one individually, but then the code is universal between them. I'm not duplicating it. All right, so next, let's start with the move script. The move script, we're effectively going to get the mouse position right away. That updates the variable that is generally available for the rest of the class to use. So we get that mouse position. And then the first thing we do is check to see, has it changed? If it hasn't changed at all, then we just say that the mouse moved is false, and then we return. We're not going to do anything else during this script. Now, assuming that it has moved, we're going to say that the mouse moved is true. We're also going to set the previous mouse position to equal our current one. And finally, we're going to call the response.move handler with the mouse position. Now, it's important to note that when we are moving, we also don't want to call this event if we are in a drag state. So if we're dragging something, the first thing we do is check to see if any of the buttons are dragging the item. And if they are, we exit before we call the handler. Okay. Next, we get to handle mouse zoom. So on handle mouse zoom, we're going to get the input delta. That's the mouse scroll delta, and it returns a vector 2. But most mice I know have only a one-dimensional mouse scroll wheel, so we're really only going to use the Y value. All right, so we check to see if the delta is 0, because a delta will always return the change, so it's 0. And if this means if nothing happened, then we return right away. Otherwise, we will call the response zoom handler. So we're calling the action, all the listeners that are listening for zoom changes. We're passing out the Y, the amount of scroll change, which is effectively a +1 or a -1. And we're calling out the mouse position at that time. The last function in here, and by far I would say the most complicated and important, is the mouse move or the handle mouse check. So handle mouse check is going to detect all of those button click and drag states and then pass those events out. So this one changes its state several times, so I have more comments inside of this one to kind of explain that along the way. All right, so first off, let's get the mouse button. Then we're going to get the current mouse down state. So we're finally asking input.get mouse button down, passing in the button ID. And now we're going to detect, was the mouse pressed this frame, and was the mouse released this frame? We're obtaining that by taking a look at, were we previously down, and what is the current down state? And of course, we reverse these for the released version of it. Finally, after we've done these, we no longer need to use the previous down, as we were using that to determine whether or not we released or pressed it this frame. So we're setting that back to what it needs to happen right at this frame, and then make sure that we do not call the down button any other time in here, or the down variable. Okay, first thing that I'm checking is if the mouse was released this frame. This is one of the key events. This is where we're going to decide between click and double click. This is also where we're going to decide between, or if we are ending a drag statement. Well, sort of. That will happen in a different spot. Okay, so the first thing, the single click means that we are clicking down and up in a short time and close enough to each other. We're going to be checking part of that in a minute. So we're going to get the time passed. We're going to say, well, the time, real time since startup. I'm using real time since startup. I'm not using delta time and keeping track of it. I'm using the real time since startup, and I'm storing that information from when the mouse was pressed down. So the mouse was released this frame. That means it wasn't pressed this frame. We will be storing it when it gets pressed. We'll be storing the time for that. So we're basically getting the time that it was stored, and we're subtracting that from the current time. And that gives us how much time has passed between the press and the release. Next, we're checking to see if this is within single click time. So if the time passed is less than or equal to the click max release time. Then we're going to set the previous value for the mouse pressed time. This is how long the button was pressed. We're going to set it to the current real time since startup. That way we can keep track of this, and this will come in handy for checking double click later. All right, double click is an down, up in short time and close enough together. So again, we check how much time has passed, checking for the previous mouse released time. And then we're also seeing, is it within the double clicked time? And if it is, we effectively just check how much time has passed and compare that with the double click max time for second click. And then at this point, we are releasing, or we're setting the previous release time for next time around, which was used here. Okay, finally, we're going to get the distance. So we've checked to see, has the time happened, but if the mouse moves enough, then we are entering a drag event, and so the click and double click events should not occur. So for here, we're checking the distance from the current mouse position to the previous mouse pressed position. This is important. Every time that we press the button down, we are detecting where that button was. So you can see we're setting the value down here if the mouse was pressed this frame. So this means it'll be for the previous one. Okay, distance right there. So on this one, we're getting the distance from where we are now compared to where we were when we first pressed the button down. And then we're seeing if that distance is greater than the setting for it. And if it is, both of these get disabled. Now we check to see if either of them are enabled. If we're in the double click time, then we're not going to trigger another single click. Now, if we're in the double click, and we also, of course, trigger the double click event. Now we're going to check to see if we're within single click time, and also, of course, make sure we're not in the drag state. If we were in a drag state when we did this, then we also don't want to trigger the clicked event. All right, so within the single click time, one other thing on this, I'm not going to get into it now, but you'll notice that every double click has a single click before it, and there is a good explanation for that, and you can watch a separate video to explain how that works. All right, the next one is we have just completed the mouse released this frame, or at least part of it. You'll notice there were no early exits leaving the function early there. So if we get to here and the mouse was pressed this frame, then we're going to store the time that the mouse was pressed, because after this, nothing else needs to use this information. All right, next we're going to check to see if we're also set the previous mouse button pressed and its position. So we're tracking its time and its position of when it was pressed. Okay, so for the next section, we're moving down to the drag statements. So we're going to check to see if what the current button down state is. Is the mouse button currently down? And we check that up here at the beginning. All right, so if the mouse button is currently down and the previous button was not in drag state, we're going to check to see if it is now in drag state, or we should put it into a drag state. So to do that, we're going to check how much time has passed, and we're also going to check how much distance was taken into account. We could speed this up by checking them separately, but that would be pretty minute. However, it would reduce a distance call, so maybe not that minute. Okay, so a distance since the mouse was pressed, we use vector2.distance. We're getting the distance between when the mouse button, where the mouse button was pressed down, and our current position. And then, of course, checking the times as well. And we're going to switch to drag if the time pressed is greater than the max time for release, and same thing for the distance move if it's greater than the click max distance. So that gives us a Boolean to switch to drag. And so if we switch to drag, then we are going to call the drag start event. We are not calling the drag start event from our current position, because the drag start doesn't actually happen until about 0.3 seconds after. So we're going to call the drag start from the initial mouse position when the button was pressed down. That means that if we happen to have moved off of the element already, it's okay, we'll still have clicked on that particular element. And then immediately after, we're going to call the drag move. So any type of initialization code that's needed can be triggered and called. But then it also gets its move event right away, so it can move it to the frame and position it's supposed to be at. Additionally, we set the previous in drag state to true. So now we know that this button is currently dragging something, or at least it's in a drag state. Now, if we were not, so this was checking to see if we were not in a drag state. Now this one assumes that we are in a drag state, but it's also checking to see if the mouse moved. So we're going to throw the drag move event, but of course only if the mouse moved. Finally, we get out of this stuff, and after all this, if the mouse did release this frame and it was previously in a drag state, then we're going to set the in drag state to false and call the drag end event. And that's it. That is everything for this. So we just covered the generation of an interaction manager. In the next video, I'll plan to cover the selection manager to use for drones. If you have any questions, thoughts, or ideas, leave a comment or join Patreon so you can chat with us in Discord.